Okay, in this video we're going to talk about Unit 8, Objective 1, Finding Position. This is going to be coming from an equation where we have velocity and we need to get back to position. So the question we're going to look at in this video is a particle with initial position of 9 has a velocity modeled by v of t equals t squared minus 8 over the quantity t plus 1 squared. And they want to know what the position of the particle is at t equals 1. So we're starting with velocity. We need to end up at position. So if we think about the relationship between position, velocity, and acceleration, if I'm going to go from velocity to position, I need to take an antiderivative. I need to either antidifferentiate or integrate depending on what the question is asking. If they want just the formula for the position, we would antidifferentiate, but since we want to know the actual position, we're going to want to integrate. So we want to integrate from 0 to 1 because they tell us something about the initial positions. That's time t equals 0, and we want to know the position at 1, so we're going to integrate to 1, and we're just going to integrate v of t. So t squared minus 8 over t plus 1 squared with respect to t. So we want to do this again because if we're integrating, the integral tells us the total change in the antiderivative. The antiderivative of of velocity is position. We want to know the total change in that position so we can figure out what the position actually is. This problem is going to need to be split up into two separate integrals because we need a u substitution in the second one. So we're going to go 0 to 1 of t squared dt minus the integral from 0 to 1 of 8 over the quantity t plus 1 squared dt. And if we look at that, we're going to need a u because we have parentheses. So our u is going to be equal to t plus 1. Our du is going to be equal to just dt. So that's good. There's nothing to really cancel out there. We're going to need to change our limits of integration. So we're not going to go from 0 to 1 anymore. We're going to go from 1 to 2 of 8 over u squared du. And then this is still going to be 0 to 1 of t squared dt. So we can integrate that first part. The antiderivative of t squared is going to be 1/3 t to the third, and we want to evaluate that from 0 to 1. We can rewrite that second integral as 8 times the integral from 1 to 2 of u to the negative second du. That way we can increase and divide. So then we're going to say minus, because there's a minus in between our two integrals. 8, if we increase and divide, we are going to have u to the negative first power divided by negative 1. We can make that a plus now. And we're going to integrate that part from 1 to 2. So looking at this, we can plug in 1, we're going to get 1/3. Plug in 0, we're going to get 0, so that first part's just 1/3. Plus 8 over 2 minus 8. 8 over 2 is going to be 4. 4 minus 8 is negative 4. And then that's going to give us, what, negative 11 thirds. So what we just found is not the actual position. What we found is what's called the displacement. So I'm going to put a little box around this thing, and we're going to call this the displacement. And the displacement is simply how far you are from your starting point. So how far you are from your starting point. And that should make sense because we know that an integral tells us the total change in the antiderivative. If the antiderivative of velocity is position, we just found the total change in the position. How far have I moved from where I started? Now, that's not answering the question. The question does not want the displacement. The question wants the actual actual position. So we need to think about this as our new position equals the initial plus the displacement. Right? So if I take what I started with and I add how much I've changed to that, then I'm going to get my new position. So our new position in this case is going to be equal to where I started, which was 9, and then we add our displacement, which is 11/3. So our new position is going to actually be 16/3. So 16/3 is the answer. So again, the integral of velocity does not tell us the position, it tells us the displacement. Our new position is going to be the initial plus the displacement. So that's going to do it for this video. We'll see you in the next one.